السلام عليكم ورحمة الله وبركاته. النهاردة إن شاء الله إحنا هنكمل topic 4 stoichiometry. في السيشن اللي فاتت إحنا وقفنا عند ال 4 main rules of stoichiometry. ال 4 main rules دول كانوا connect a number of moles ل different things. بمعنى هما كانوا connect the number of moles to the mass, number of moles to the volume, number of moles to the concentration and volume of solutions, و a number of moles to the number of particles. دايما لما اجي احل stoichiometry انا برجع ل number of moles. بمعنى لو انا given mass بحولها number of moles، لو انا given volume بحوله number of moles، concentration and volume for solutions برضه بحوله الى number of moles and same for number of particles. طيب recap كده على ال 4 rules دول. a number of moles equals the mass in grams divided by the relative molecular mass or the relative atomic mass. relative atomic mass بتيجي directly from the periodic table. relative molecular mass هي عبارة عن summation of the masses of the atoms forming a compound. The number of moles also equals the volume in decimeter cube، والرول دي أنا بستخدمها لو أنا عندي gas divided by 24، لأن احنا اتفقنا إن Avogadro stated that 1 mole of any gas at RTP occupies a fixed volume of 24 decimeter cube. واتفقنا ان انا لو عندي في الكويستشن بتاعي الفوليوم in centimeter cube لازم احوله الى decimeter cube by dividing by 1000. Third rule، لو انا عندي solution acid base number of moles equals the concentration in mole per decimeter cube. concentration ده لازم يبقى in mole per decimeter cube multiplied by the volume in decimeter cube. طيب in some questions ممكن يطلب مني ال concentration in gram decimeter cube. هعمل ايه؟ هجيب ال concentration in mole decimeter cube and multiplied by a relative molecular mass. Final rule، لو أنا عندي number of particles، number of moles equals the number of particles divided by Avogadro's number اللي هو 6.02 multiplied by 10 to the 23rd. واتفقنا إن احنا دايما نرجع ل number of moles. طيب let's take an example. عندنا 200 grams of pure calcium carbonate are heated strongly. Calculate the mass of calcium oxide. تمام، هو عايز الماس بتاعت الكالسيوم oxide and volume of carbon dioxide produced. اوكي، انا عندي ادي الكالسيوم كربونات والكالسيوم oxide. المول ريشيو بتاعتي من الايكويجن 1 to 1. عرفت منين؟ هنا مفيش coefficient، طالما مفيش coefficient يبقى 1. هنا 1 mole of calcium carbonate وهنا 1 mole of calcium oxide. طيب أنا عندي 200 grams of pure calcium carbonate، ما ينفعش أعوض بيه 200 grams دول هنا، لازم أconvert ل number of moles الأول. يبقى number of moles بتاع الكالسيوم carbonate equals الماس 200 divided by a relative molecular mass بتاعت الكالسيوم carbonate اللي هي 40، ده للكالسيوم plus 12 relative atomic mass بتاعت الكربون plus 3 لأن أنا عندي 3 oxygen atoms multiplied by 16 اللي هي relative atomic mass، يطلع عندي 2 moles. اوكي طيب يبقى أنا هنا عندي 2 moles. أنا دلوقتي محتاج أجيب إيه؟ محتاج أجيب ال number of moles بتاع الكالسيوم أوكسايد. هجيبه إزاي؟ scissors way. يبقى أنا عندي ال number of moles بتاع الكالسيوم أوكسايد equals 2 moles. هل أنا كده حليت المسألة؟ لأ، لأن أنا لسه ما جبتش المطلوب، هو عايز الماس بتاعت الكالسيوم أوكسايد. يبقى أنا هقول له إن الماس equals the number of moles multiplied by a relative molecular mass equals 2 multiplied by الكالسيوم 40 plus الأكسجين اللي هو 16 equals 112 grams. اوكي ده كده المطلوب الأول. طيب هو عايز الفوليوم of carbon dioxide produced. تمام، احنا عندنا الجيفن داتا بتاعتنا عن الكالسيوم كربونات، فاحنا لما نيجي نحل السؤال بتاعنا هنستخدم الكالسيوم كربونات، مش هنستخدم النمبر اوف مولز بتاع الكالسيوم اوكسايد. ليه؟ هو غلط لو احنا استخدمنا الكالسيوم اوكسايد؟ لا، ما هوش غلط، لكن لو احنا واحنا بنحسب طلع عندنا النمبر اوف مولز بتاع الكالسيوم اوكسايد خطأ فرضا يعني، وانا عوضت بيه في المطلوب التاني، يبقى كده الاتنين ريكوست اللي في السؤال ضاعوا. فانا دايما ارجع للي هو عاطيهولي في المسألة. اوكي طيب، يبقى احنا هنا هنعمل relation between الكالسيوم كربونات والكربون دايوكسيد. اوكي، ده الكالسيوم كربونات وده CO2. المول ريشيو بتاعتي برضو 1 ريشيو 1. احنا حسبنا النمبر اوف مولز بتاعت الكالسيوم كربونات، خلاص طلعناها ب 2 مولز، يبقى انا عندي هنا 2 مولز من الكربون دايوكسيد. اوكي طيب، دلوقتي انا محتاج اجيب الفوليوم بتاع الكربون دايوكسيد. الفوليوم equals the number of moles multiplied by 24. يبقى 2 multiplied by 24 equals 48 decimeter cube، لأن احنا بنتكلم عن volume. Next question. Calculate the volume of 1 mole decimeter cube of solution of sulfuric acid required to react with 6 grams of magnesium and the volume of hydrogen produced at RTP. تمام، احنا عندنا هنا concentration بتاع الايه، السلفوريك acid، هو عايز الفوليوم بتاعه. اوكي، يبقى احنا هنعمل relation between المغنيسيوم والسلفوريك acid. طب اشمعنى المغنيسيوم والسلفوريك acid؟ لان الجيفن داتا بتاعتي والريكوست مرتبطين بالمغنيسيوم والسلفوريك acid. انا عندي الماس بتاعت المغنيسيوم هنا، وعندي الكونسنتريشن بتاع السلفوريك acid. المول ريشيو بتاعتي هي 1 ريشيو 1 من الايكويجن. عندي 6 جرام of magnesium، لازم أحولهم إلى number of moles. Number of moles equals mass divided by the relative atomic mass of magnesium من ال periodic table. relative molecular relative atomic mass بتاعت المغنيسيوم equals 24. 6 divided by 24 equals 0.25 mole. اوكي، يبقى أنا هنا عندي 0.25 mole. ال 0.25 مولز دول هيتفاعلوا مع قد ايه من السلفوريك اسيد scissors way. يبقى انا هنا عندي 0.25 moles of sulfuric acid as well. طيب، احنا دلوقتي عايزين الفوليوم بتاع السلفوريك اسيد. الكونسنتريشن بتاعي بالمول ديسيمتر كيوب، يبقى انا اقدر استخدمه في الرول بتاعتي على طول. الفوليوم will be equal to the number of moles multiplied by the concentration 1 equal to 0.25 decimeter cube. طيب، بعد كده هو عايز الفوليوم of hydrogen produced at RTP. يبقى أنا هعمل إيه؟ هعمل relation ما بين المغنيسيوم والهيدروجين produced. يعني المغنيسيوم والهيدروجين برضو المول ريشيو هي 1 ريشيو 1 من الإيكويجن. أنا هنا عندي 0.25 برضو scissors way. أنا هنا عندي 0.25 moles of hydrogen. عشان أجيب الفوليوم will be equal to number of moles multiplied by 24. يبقى 0.25 multiplied by 24 be equal to 6 decimeter cube. في نوت كده بتقول لي in for reactions involving only gases the volume ratio equals the mole ratio in the balanced equation. طيب هو ده جه منين؟ احنا اتفقنا ان 1 mole of any gas occupies 24 decimeter cube at room temperature and pressure. يبقى a number of moles equals the volume divided by 24. Okay, طيب ال 24 ده constant. تمام، فمنه أقدر أستنتج إن a relationship between a number of moles and volume is a direct relation. Okay, فلما يكون عندي الرياكشن بتاعي كله in gaseous state، أنا مش محتاج convert من number of moles to volumes. لا، أنا ممكن أستخدم المول ريشيو ومعها أستخدم الفوليومز directly من غير ما أعمل الكونفرجن، لأن هي تطلع نفس الريشيو في الآخر، لأن أنا دايما dividing by a counts. Calculate the volume of methane needed to react with 70 decimeter cube of oxygen. طيب احنا عايزين volume of methane، احنا هنعمل relation between CH4 methane and oxygen. الريشيو بتاعتي المول ريشيو من الإيكويشن هي 1 ratio 2. هنا الرياكشن بتاعي is all in gaseous state، فأنا مش محتاج أعمل conversion للفوليوم، فأنا هنا هستخدم السفني زي ما هي بالظبط، وهطلع الفوليوم بتاع الميثين scissors way. يبقى الفوليوم 70 multiplied by 1 divided by 2 equals 35 decimeter cube، من غير ما أعمل conversion لل number of moles إلى volume أو العكس. The volume of carbon dioxide produced at RTP، فاحنا هنا هنستخدم الأكسجين مع الكربون دايوكسيد، فهتبقى 2 ratio 1. الفوليوم بتاع الأكسجين 70، عشان نجيب الفوليوم بتاع الكربون دايوكسيد هنستخدم scissors way، يبقى الفوليوم will be equal to 35 decimeter cube as well. Okay. Find the volume needed to react completely with 15 grams of ethane. هو عايز الفوليوم of oxygen to complete with 15 gram to react completely with 15 grams of ethane. يبقى احنا هنعمل reaction أو relationship between C2H6 and oxygen. هنا عندنا 1 mole، هنا عندنا 3.5 moles. طيب 3.5 دي جت منين؟ 7 divided by 2 equals 3.5. okay. احنا عايزين بقى ال number of moles بتاعت الإيثين N will be equal to the mass 15 divided by relative molecular mass of ethane 2 divided by 12 plus 6, which will be equal to 0.5 mole. And I put the 0.5 mole. Now to calculating the number of moles of oxygen. Scissors way. And then 0.5 multiplied by 3.5 divided by 1, which is 1.75. Okay. Now to calculating the volume. The volume equals the number of moles multiplied by 24. Sorry, multiplied by 24 equals 42 decimeter cube. What volume of carbon dioxide at RTP will be formed when 50 grams of calcium carbonate reacts with an excess of hydrochloric acid as shown below? هو عايز الفوليوم of carbon dioxide. Alright. احنا هنعمل relation بتاعتنا between الكالسيوم carbonate والكربون dioxide. Okay. الريشيو بتاعتنا هي 1 ratio 1. And then 50 grams of calcium carbonate. احنا هنجيب number of moles equals 50 هي mass divided by 40 relative atomic mass of calcium plus 12 plus 3 multiplied by 16 equals 0.5 moles. يبقى هنا أنا عندي 0.5 mole of calcium carbonate. Scissors way أجيب a number of moles of carbon dioxide هيطلع ب 0.5 mole. بعد كده أجيب الفوليوم number of moles multiplied by 24 and 12 decimeter cube. 16 and 17 are the same idea. You can answer them and check your answer right here. This is the answer. If you have any problem with them, you can ask me on the Telegram group. You'll find the link in the video description. Question number 18. Calculate the mass of silver formed when 5.52 grams of silver carbonate are heated and find the volume of gases produced. Okay. we're gonna form a relation between silver carbonate, Ag2CO3, and silver itself. The mole ratio from the equation is 2:4, and we have 5.52 grams of silver carbonate. So we're gonna calculate the number of moles that 5.52 represents. So that's the mass divided by the relative molecular mass of silver carbonate. That's 108 108 multiplied by 2, because we have two silver atoms right here. We have two. Okay, so 2 multiplied by 108 plus 12 plus 3 multiplied by 16. Okay, that equals 0.02 mole. Now we put that 0.02 mole right here, and using scissors way, we're gonna get the number of moles of silver. So N, number of moles for silver, equals 0.02 multiplied by 4 and divided by 2. Okay, that's 0.04 mole. Now we need to calculate the mass, I guess. Calculate the mass of silver formed. Yeah. Now the mass of silver itself equals the number of moles multiplied by the AR, the relative atomic mass, 0.04 multiplied by 108. That will be equal to 4.32 grams. Okay. Now we need to calculate the volume of gases produced. Here we have 2 moles of carbon dioxide and 1 mole of oxygen. So the total number of moles of gases formed is 3 moles. So if we want to make a relation between Ag2CO3 and the gases formed, it will be 2:3, and here we have 0.02 moles. So again, scissors way, the total number of moles formed for the gases will be equal to 0.02 divided by 3 divided by 2, which is 0.03 mole. Now calculating the volume equals the number of moles multiplied by 24. 0.03 multiplied by 24 equals 0.72 decimeter cube. Okay, next question. Find the volume of ammonia gas formed when 1.605 of ammonium chloride is heated. Okay, we need the volume of ammonia gas. So we're making a relation between ammonium chloride and ammonia H3. Okay, here we have 1:1. That's the mole ratio. Here we have the number of moles for ammonium chloride is the mass divided by the relative molecular mass of ammonium chloride. So from the periodic table, nitrogen is 14, has an AR of 14 plus 4 plus 35.5 for the chloride equals 0.03 mole. Now the volume will be equal to 0.03 multiplied by 24, which is 0.72 decimeter cube. Question number 20. In an experiment, 25 centimeter cube of aqueous sodium hydroxide, 0.04 mole decimeter cube was neutralized by 20 centimeter cube of aqueous oxalic acid, H2C2O. Okay. Calculate the number of moles of NaOH in 25 centimeter cube of 0.04 mole decimeter cube solution. Very well. We need the number of moles. First of all, we need to convert the concentration from centimeter cube into, the volume from centimeter cube to decimeter cube. So the volume will be equal to 25 divided by 1000, 0.025 decimeter cube. Right. Now we need to calculate the number of moles, concentration multiplied by the volume, 0.04 multiplied by 0.025 equals 0.01 mole. Now, use your answer in A to find out the number of moles of oxalic acid in 20 centimeter cube of solution. All right. The relation between sodium hydroxide and oxalic acid, H2C2O, 4 is 2:1. So if we have 0.01 moles, using scissors way, we're going to get the number of moles of H2C2O, 4. Okay, so the number of moles will be equal to 0.01 divided by 1 divided by 2 will be equal to 0.005 mole. Right. Now calculate the concentration of the 0.04 mole decimeter cube NaOH in gram decimeter cube. Right. So we have the concentration in mole decimeter cube. Let's calculate it in gram decimeter cube. So the concentration in gram decimeter cube will be equal to the concentration in mole decimeter cube multiplied by the relative molecular mass of sodium hydroxide, which is 23 plus 16 plus 1. Okay, which equals 1.6 gram per decimeter cube. Okay, calculate the concentration in mole decimeter cube of the aqueous oxalic acid. Okay, so we have the number of moles of oxalic acid, which is 0.05 moles. Now we need the concentration. The concentration equals the number of moles divided by the volume, equal to 0.05. That's the number of moles, 0.005, sorry, divided by the volume, 20 centimeter cube. Yep, 20 centimeter cube, which is 0.002, 0.25 mole decimeter cube, because that's a concentration. Right. Now, how many moles of copper are required for the production of 15 moles of water for the following reaction? Okay, we're going to form a relation between copper and water. That's copper and that's water. The mole ratio from the question is 1:5. We have 15 moles of water. Okay, so how many moles of copper will be required? Scissors way, the number of moles will be equal to 15 multiplied by 1 divided by 5. That will be 3 moles. Okay, now let's talk about another rule, the percentage purity. It's calculated using this rule, the calculated mass of the reactant divided by the given mass of the reactant. The calculated mass is the mass you calculate from the chemical equation, divided by the given mass of the reactant, which is given in the question, which is the given mass of the reactant that you used initially in your reaction. For example, with 10 grams of impure zinc, that's the given mass, reacted with diluted sulfuric acid, 2.4 decimeter cube of hydrogen gas were given out or collected at RTP. Calculate the percentage purity of zinc. Okay, so we're gonna make a relation between zinc and hydrogen, 1 mole to 1 mole from the equation. We have 2.4 decimeter cube of hydrogen gas were given out, right? Okay, so the number of moles for hydrogen will be equal to volume divided by 24, which is 0.1 mole. Now we have 0.1 mole here in hydrogen. Now we're gonna make scissors way to get the number of moles of zinc. So N for zinc will be equal to 0.1 multiplied by 1 divided by 1, which is 0.1 mole. Okay, so that's the number of moles for zinc. Now we need to measure the mass of 0.1 moles for zinc. So the mass will be equal to 0.1 multiplied by 65, which is the relative atomic mass for zinc, 6.5 grams. Okay, now we need to calculate the purity percentage for zinc. The purity percentage will be equal to percentage purity. The calculated mass, which is 6.5, that's the mass that was actually given out of the product, divided by the given mass of the reactant, which is 10 grams, multiplied by 100 because it's a percentage. So the answer will be 65%. 2 grams of an alloy, copper and aluminium, reacted with hydrochloric acid. 2.4 deciliter cube of hydrogen evolved. Calculate the percentage purity of aluminium in the alloy. طيب اشمعنى الالومنيوم? Because only aluminium will react. There is a concept called the reactivity series. We'll discuss it later. Copper is below hydrogen, so it doesn't replace it in its solution, right? So aluminium will react while copper will not be reacting. So we have 2.4 decimeter cube of hydrogen were evolved, right? So we're gonna make a relation between aluminium and hydrogen, right? We have 2 moles of aluminium react with 3 or given the result 3 moles of hydrogen from the equation. We have 2, we have 3, and we have 2.4 decimeter cube of hydrogen. So we need to convert that to a number of moles. Number of moles equals the volume divided by 24. 2.4 divided by 24 equals 0.1 mole. Now 0.1 mole right here. Scissors way, we're gonna get the number of moles for aluminium. So N for aluminium will be equal to 0.1 multiplied by 2 divided by 3, right? 0.067 mole, right? Now we need to calculate the mass of aluminium, which will be equal to the number of moles multiplied by the relative atomic mass. 0.067 multiplied by 1.8 grams. Okay. Now to calculating the percentage purity. The calculated mass divided by the given mass multiplied by 100, 90%. Now we need to discuss the percentage yield. The percentage yield gives you an indicator of how much product was given in relation to the actual amount that was supposed to be given it, if the reaction was carried out without waste and in optimal temperature. So it's measured through this rule. The percentage yield equals the actual mass divided by the calculated mass multiplied by 100. So the actual mass is the mass that was given out after you completed your chemical experiment. It's given in the question in most cases. The calculated mass is the theoretical mass that you measure from the chemical equation. It's the mass of the product that was supposed to result in if there were no waste and at optimal circumstances, which is technically impossible. For example, heating 12.4 grams of copper carbonate produced only 7 grams of copper 2 oxide. What is the percentage yield of copper oxide? Okay, so we have copper carbonate and copper oxide. So the relation will be in between copper carbonate and copper oxide. The mole ratio is 1:1 from the equation. We have number of moles equal to 12.4 divided by the relative molecular mass for copper carbonate, which is 64 plus 12 for carbon and 3 oxygen atoms, and 3 multiplied by 16, which will be equal to 0.1 mole. Okay, now we have 0.1 mole of copper carbonate. How many moles of copper oxide are we getting? Scissors way. N for copper oxide will be equal to 0.1 mole. What's the mass of 0.1 mole? So the mass will be equal to the number of moles multiplied by the relative molecular mass for copper oxide, which is 64 plus 16, which equals 8 grams. Now to calculating the percentage yield, which will be equal to the actual mass, 7 grams, divided by the calculated mass, which is 8, multiplied by 100, equal to 87.5%. Of course, we didn't use the 12.4 grams in the final step because we are measuring the yield of the product, which is copper oxide. So we use its mass and its calculated mass. The percentage composition of element in a compound. It's one of the easiest rules in stoichiometry. It tells you how much a certain element comprises of the whole compound. Let's measure using this rule: the number of atoms of an element multiplied by its relative atomic mass divided by the relative molecular mass of the whole compound multiplied by 100, because it's a percentage. The percentage composition of nitrogen in the following. So just to make it easier for us, nitrogen has an AR of 14. Okay. Ammonium nitrate, NH4, NO3. Ammonium, NH4, nitrate, it's a group, a radical, NO3. Okay. So the percentage composition for nitrogen will be equal to, how many nitrogen atoms do we have? We have 2 nitrogen atoms. That's one. That's the second one. So 2 multiplied by 14 divided by the relative molecular mass of the whole compound, which is 2 multiplied by 14 plus 4 multiplied by 1 plus 3 multiplied by 16. All of that multiplied by 100 because it's a percentage. So that nitrogen comprises 35% of the whole compound. Another example, ammonium sulfate. Ammonium is NH4, sulfate is SO4. Sulfate has a valency or a charge of 2, and ammonium has a charge of 1. So scissors way. The structure or the formula for the compound will be NH4 all 2 SO4. Okay, now the percentage for nitrogen will be equal to, how many nitrogen atoms do we have? Also, we have 2 nitrogen atoms, because this 2 out here is multiplied by the nitrogen in here. 2 multiplied by 14 divided by 2 multiplied by 14 plus 2 multiplied by 4 equals 8. So we have 8 multiplied by 1 for hydrogen plus sulfur, 32 plus 4 oxygen atoms, all of that multiplied by 100, which will be equal to 21.2%. Calculate the percentage composition of hydrogen and oxygen in H2O. That's a very simple example. You can answer it yourself, and the answers are right here for you to check them out. The percentage composition of H2O in copper sulfate, hydrated copper sulfate, and the percentage composition of oxygen itself. Okay, you can also answer this question yourself, and the answers are right here. If you have any problem with these questions, you can ask me on the Telegram group. You'll find the link in the video description.